Okay, thank you for the invitation. And I'm glad to show you something we've done last month. And last year I was invited. We spoke about how to extract chemical. Speak louder. No, it's fine. And today, the focus is a little bit more on visualizing results. So we are here in the chemistry or cheminformatics group. I'd like to focus a little bit more on chemistry or documents and information. And I start with, okay, how is chemistry represented? We saw it today. Daniel showed it. We can show it you again. It's a lot of different kind of names. Might be compound trees, sildenafil, Viagra, Japanese, Chinese terms, and so on. A lot of labels. This is killing you when you're trying to map together information coming from different sources. But it's much more. You have images. Everybody heard Osra Clyde today. There might be Mago as well. And to state, I would also say Clyde much better. We have chemical information hidden in the tables, which might be a compound number, something else. Molecular attachment files, pretty often coming with patterns. And then you have chemistry, which is associated with plenty of data. And this is more or less what I like to focus on today. So you have data coming from toxicity, bioactivity, PK, PD, a lot of different ones coming from different data sources. And one aspect is physchem properties coming from experimental levels, so internal data. And also a way to bring out data coming from external versus external data. So technologies we're using, I try to rough them up. So we're using KNIME as a pipelining tool, pretty good. Chemical recognition, ChemAxon, KNIME nodes, command line tools. We're using text mining tools like linguistic I2E and OSR tools like Clyde and in part Osra. What's adding to this year is visualization. ChemCurator is one aspect and Plexus is the other one. When I was invited, people were thinking I would speak about workflow pattern curation. Janos asked me. I say, no, just a really short update. It's one slide. This is the slide I showed you last year. This is how our pattern curation workflow is working. So there's an input. It might be Excel files or just a list of patent IDs. These are processed, all the attachment files are retrieved. And we have two branches where all the chemical informations which might come from molecular images or attachment files or text are converted, and in the end you have a fully chemically indexed patent document which is used to extract bioactivity data. Sorry. Results usually exported either as SDF file or as an Excel sheet, or we might load them up into ChemCurator. And this is just a part of the compound view. And here there's some new columns which are just brought in automatically. And thanks to the advantage within ChemCurator to have an automatic mapping of all the existing chemistry to what is present in the text, you can have an automatic association, I don't know, for bioactivity data, for example, which is appearing at page 260 of the patent, with each single chemical aspect you might present in the rest of the document. And so you have a full SIR table at the end, just by hand. As a short update, well, still no full automation possible because there are too heterogeneous data along the different patent offices. Using KNIME, we have more workflows, so we set up a kind of flexibility which might be able to handle this. Time and computational resources was a pain point last year, still it is, but we expanded on a larger CPU notebook and a server. So this is much more helpful. We can process much more data now. We have a novelty checking where we now try to compare preferred IUPAC name and traditional names. Once they're the same, usually this is a new compound. And we have an improved handling of OCR errors within the documents, which is usually a killing point. So patents work quite fine. People was happy by the data delivering them. And we tried to bring in these new tools I showed you. So OCR tools, OSR tools, chemical recognition. And the question was, well, what's now? What can we do else with other kind of documents, not only patents? And we had three use cases. They came out by chance, more or less. I'm smoking a cigarette, having discussions with people coming from the lab, for example, like in case one. Case 2 was a different idea on how can we represent databases which are now out on the public view, on a web page, but you can't really search them how you would like to search them. And in the third case, it's internal documents and what can we make out more of docx file or document files. For all three, I use Plexus as a front end. It was a really handy tool in order to make out something flexible, interactive. I showed out first results, first views to the patents, to the people. They told me, no, I don't like this much, and we changed it. This was really good. So the first point, I met several chemists or laborant chemists which told us, well, we can search for chemical information within SciFinder or Reaxys. We pop up with 200 synthetic routes. The most difficult aspect is reduce them to the best routes, because in 80% of the cases, the data which you present on SciFinder are not correct. The yield is not correct. The reaction is not working as they should. But all these people told me, well, we have a collection of PDFs and of synthetic routes stored in a folder. We have, don't know, 2 GB of PDF files saved. And we know that this is a really good basis in order to find reactions. But we can't search through these PDFs. So this was the first idea. And I was speaking with Luz around the camp, say, hey, we would like to search a way to find out reactions from documents. And the idea was, okay, where is my reaction? Or which kind of PDF should I read through? And speaking by that, we thought, okay, but might be also a good way to share your experiences and show and share what you find with other colleagues, which also had some kind of collection of PDFs with good working synthetic routes. And this is more or less the workflow, how it's run through. We have an FTP folder where we can throw in PDFs. On these PDFs, there is several processes running on. So we have a chemical recognition. It's a name to structure, document to structure. There's some OSR tools in there. We have a linguistic reaction pattern recognition, meaning you have to understand how a chemical reaction is described by text. And then we have the chemical reaction extraction and the splitting into different components, having a reactant, a product, and so on. The annotation part is done on Brad. This is essential in order to train your algorithms and make this recognize. And in this way, we can assign a different role to the different chemical entities which are found here. And just said shortly, we have different properties which might be associated, which can display it or not, depending on what you're looking for. Well, this is how it looks like at the end when we're showing out the results to the people. We have one page where we have the chemical reaction. We have the original text where the chemical reaction is taken from. We have the indication where the file is and all the different informations down here. And you can search this through now. You have your search field. You can search chemically. You can search by text. You can search for different solvents. There were some issues which we were not that happy, and I will present them at the end, saying which were the pain points we experiencing in. Some of them already have been solved, so excellent. And the idea was, okay, this is one way how we can give the people the chance to search through databases and to search for reactions. There are 2 aspects missing here now, and this is what's more or less future plans. I can't show you, but ideally, here there might be something like a comment bar. It might be great to have people done one reaction and saying, oh, I've done this reaction, changing reagents, and bring in this information, having like a comment field here. And as well, what is missing right now is to have a direct link out to the original source. But this is ongoing still. The next aspect was, okay, can we exploit database searches in a different way? So you have classic databases where you have your chemical search. You might search for specific fields which are given, which has been indexed initially. This was not enough sometimes. I think databases like DrugBank, for example, are hiding a lot of information in the text boxes, which you usually can't search through. You can't filter. And this was the main reason, say, okay, let us bring them in and let us see if we can exploit them in a better way. So usually we have an upload of the content. For example, DrugBank has a raw XML file or an Excel sheet, a CVS, whatever you have. We need to map the databases. For example, via Instant JChem, trying to make out a one-to-one, one-to-many, many-to-many relationship, which might be great if you want to map, for example, DrugBank and Campbell, looking for different targets present in there. You would be astonished. And then at the end is, okay, once we have mapped and extracted all these informations, I'm part of a scientific information center at Boehringer Ingelheim, and we have a lot of customers who came to us and ask for information. And this came out at the end to having custom views, which are specific for the different departments which are asking us. This is the final sheet where we have it in the end. We have now drug bank imported with a mapping on Campbell, for example, and we can search, like here. You make a substructure search, you can diversify it. But we can also add text-based informations which else are not possible, for example, like in drug bank. And we can search within metabolism, we can search within a route of elimination. And all this information is now just presented as a plain text. Of course, there are other options. You might annotate this, extract preferred terms. This is more towards the future. But already this gives you the chance to say, oh, we have 8,000 hits within the database. How many are really reflecting these three aspects? And this is possible only in this way. The last aspect, okay, what can we do with internal data? What can we do with Word file? Usually they're stored into folders. Eventually one folder presents other 10 or 20 folders with some thousands of document files in there. So the idea is, how can we search through them? We need first to infer chemical meaning to these documents. And we usually want to extract and store bits of information coming from these documents. They're not always fully interested in. This might be a way to set up a kind of a company-wide repository for physchem or experimental data properties. It might also be a way to combine internal and external data. The workflow is pretty easy. We have one folder where all the docx files are present with more than once. We have a two-branch system. One is going through text mining. So we're extracting the information present in these documents, coming from both free text and tables. And we have one part which is going over KNIME and chemical reaction tools like mole convert, reaction split, which is from ChemAxon, obviously. These are then joined within KNIME, brought into Instant JChem. We create the views, and these are then displayed via Plexus. So this is one internal document, just to give you an idea. And all the yellow highlighted aspects are fields where we would like to extract information, which can be really text one and really tabled structure, like over here, which is much more easier to find. But we're also extracting information from this part here, which is within a table, but it is still a text and a free text form. And what we're delivering at the end is, okay, a Plexus view, where you have different tabs, so you can look for, I don't know, enthalpy informations which are stored within the data, or you're looking for the reaction information, or for admin metadata, like who has done this process. We have internal codes, we have a main structure, and eventually products and reagents when we split the reactions, if they're present in there. We're extracting the whole chunk of information in order to give the people the chance to see the original data. And then we extract the single information, which might be, I don't know, an enthalpic value for a specific reaction. And these are data which are stored internally, now just in Excel files or a Word file. In this way, you make them searchable in a much better way across all the different Word documents. And this is just an idea, like now you have a melting point, which is just buried within the system, just with one sentence. You can visualize it. And you can make this searchable. So different kind of documents, different kind of formats. This usually brings you to run into different issues when you're testing out new softwares or new tools like in Plexus. And I like to enlist some of the limitations of the weak points I encountered. Some of them have been solved, I found out today. Great, this is excellent. Some others probably rely on the different idea of how the tools, why the tools have been built in one way. So first one is versioning compatibilities and stability issues. Guys, I told one of you, I know why it is like this, but it is really a pain point. Having different versions of Java allows you to use different ways of Plexus, and only some and not the other. If you switch from one Instant JChem version to a newer one, your old Plexus won't work. This is really tedious. Sometimes you're not allowed to update every time a server It would be great if there is one way to having a backward compatibility, but this is something which is sometimes really annoying. You try to show out results which is not appearing anymore. So you have to go back on older versions of Instant JChem where you can't do the same thing. Prepare the data, send them out. This is really cumbersome. Another aspect we found out is if I have an empty field in an Excel file I upload within Instant JChem, for example, I get error messages like this one. Okay, the workflow is running and I can still display my results and I can search them through, but these are popping up one after the other. If I'm going through 100 rows, I will have 100 of these things filling up my field and I have to click them close one after the other. Quite boring, you can imagine. This is something has been solved, I found out today, but this was something which was really killing. We were extracting chemical reactions, I told you. Sometimes it's really good to look which is my reagent and which is my product at the end. This was not possible. It was only searchable one chemical field at a time within Plexus. Now it has been solved, Max, correct? Yes. But this was really hard. Like in SciFinder, it's hard for you to search for a reagent and a product in a different way, in a really specific way. This was one way, giving you the chance for that. And perhaps it's not perfect, but it gives you something else what you can't do. So this is no replacement for SciFinder. This is something on the top. This gives you high quality data which usually are collected internally. And the last part is, okay, limited options. There are a lot of capabilities of Instant JChem which are not reflected in Plexus. Sometimes, so like in our case, this one here is a chunk coming out of drug bank. It's an HTML chunk. It is great because it gives you exactly what is reflected by the database. If I can show out this information to the people, to my customers, they know, okay, this is the original source, I can go there and look at that. But if I'm looking at this view, so this is an Instant JChem view, into Plexus, this here is not appearing anymore. This is just an image because Plexus is not capable to handle the HTML chunks which are present in there. But this is really tedious. And having a way to find out the differences would be great. I understand that Plexus is a tool developing into one direction. I don't know if this is going to become an independent tool from Instant JChem. But if so, please make out an editor just for that in order to know what can be met, what can we find and pretend to find it. Thanks. And the other aspect really missing is if I'm making a search in Instant JChem, I have a highlight of the terms. This is not happening in Plexus. It would be great because it makes easy to see what you're looking for. It's small things, but I hope this is a stimulus in this direction. And, well, I'd like to thank all of you, or my group, some people within BI coming from MedChem and chemical development giving me idea on the chem. Thank you, Lutz. It was great to work on these tools. Questions?
It's going to be a reply and a questions at the same time. So first, the missing things, they are in the roadmap. So yeah, and actually the rendering of HTML, this should be already in again. So yeah, just try out the new version. It will be better. And my second question was to the document repository of yours. How do you handle updates when new documents, new Word documents are getting being fed into the system? Is the KNIME workflow triggered automatically and the linguistic indexing done automatically so that you can get up-to-date results? Or is there some ETL step running in advance?
Okay, what I showed you is all on a pilot project level. What has been done right now is I have a check on the original folder if there's some new documents. These are automatically taken in, sent to I2E, taken into KNIME. This is a kind of a scheduled job. And this is a constant update of the documents I'm bringing in. This gives you also the chance if you have one document, if it has been opened, edited, resaved, you have a new date, this is taken over, incorporated. Right now it is the fastest way. I was speaking with Edith, she told me, go on databases, she's right. But this is the starting point. It's much easier in this way with smaller files.
Mm-hmm. Thank you. Yeah. Maybe it's a good idea to use the database with the Oracle text combined and you will be there.
This was a great help for you, yep.
Yeah, this is more like a comment. So I think one thing what I can tell here is that Plexus is meant to be a user role-based software. So it's not a goal to recreate IGC entirely within a web client, but more like making it properly usable for various user roles. And these user roles are not necessarily facing with the same user interface. So this is one principle what we keep in mind. But on the other hand, you listed many absolutely valid point what we really need to inhire from the desktop application. Yeah, thank you.
Far be it from me to stick up for CAS, who are not chemical abstract service. They're chemical abstract service, not chemical abstract services. Yeah, maybe this is why they now call themselves CAS. And I'm not here to defend them, but I'm intrigued to know what is it that you can't do with the reaction and the reactor and the product?
So if you're making a clear search, having a generic reaction setup without a splitting, it's really hard that you can split them and separate within SciFinder, saying this is my generic reaction. Find me every time one compound is only in one area and not in the other one. This is mixing up sometimes. The results are not always straightforward in this direction.
We need to take this offline. It sounds complex,
Yes.
but okay. Yeah. Have you tried negotiating with them and telling them how much better you are?
It's very new. It's 6 months.
But perhaps adding on this, CAS is not annotating every compound. If there are more than 100, they are not taking them over. Only by this is we already saying that they are not covering the full area. I had this discussion with patent departments. We were doing the patent extraction tool. We showed them the results. And patent 1, that number of compounds. Patent 2, that number of compounds.
But they are not taking even the important ones sometimes.
Yeah.
I think you did a very bad job of defending CAS.
No, I mean...
Why they're not doing the important compounds?
No, they're sometimes missing, yeah. If you compare CAS, Derwent, Thomson Reuters, you will find 7 to 8% of compounds which are not overlapping in all the different ones.
About that recently, yeah.
But this is just showing you a glimpse of it. If you're not considering structures and images, which is not done by nor of these tools.
I'm so sorry. Well, there are also a significant number that you will find only in Reaxys.
Yes,
if you look
of
at
course.
that paper.
Of course.